Hello, the management team of Siemens Group. My name is Mohammed Shaheer, and today I'm going to present my project that is milk quality sensing using spectroscopy and machine learning. It targets a specific problem in my home country, Pakistan, that is the widespread use of milk adulteration. Recently, a Dawn News Group, that is one of the biggest news group in Pakistan, published a report that 83% of the samples they have collected is adulterated. So this poses a significant threat to public safety and health, and therefore I believe that there is a gap that exists over here which needs to be solved. So milk adulteration has a lot of health consequences, especially the level of adulterants and the type of adulterants that are being used can affect negatively the health of people, especially those that are already at risk like children and elderly people. It can pose different kind of diseases like nausea, vomiting, diarrhea, and if the detergent is being used as an adulterant, it can also cause organ damage. So what we did is that we created a customer survey and we decided to see how the market is and what are the thoughts of the people. We populated this survey among many universities in Pakistan, and there were almost 100 participants. So as we can see, most of the issues that are coming are from the three big cities of Karachi, Lahore and Islamabad. This is because most of the population is concentrated over there, and therefore due to overpopulation, the issues of milk adulteration is on the rise. So we decided that we will release our product first in these cities to see how much impact our product will have. We also asked them what milk vendor are they buying their milk from, and as expected, almost half of the participants are buying their milk from local milk shops, from people households that are selling milk on their own, and there is no standard of any quality. When we asked them to rate their quality, most of them rated it from 4 to 9, and the lower quality was usually from those who are buying locally from local milk shops. So we asked them whether they are interested in such kind of device that can instantly measure their milk quality, and almost 57% people said that yes they are, and another 25% were not sure, and they said maybe they will see and they will buy it if the device does have potential. And most of the customers wanted it to be around 10,000 rupees, that is around $40. So we will see how much our device will cost. Now, most of the people want to have such kind of device in $40, but there is no local solution that is present in our home in our country, and uh, these kind of devices are only used in laboratories for research purposes or by regulatory authorities. So we visited some laboratories and some government buildings to see what kind of devices they are using, and the most common one is Lectoscan. It is imported from abroad, and the most cheap variant of Lectoscan is around $750. So it is very expensive, and it cannot be it is not affordable by a common person. Another thing is that this device requires a lot of technical expertise and training. So this cannot be used by any person in any household. It does have to be used by some scientist who knows how to calibrate it and how to use it properly. Also, it is not portable. It is very heavy, and it has to be carried from one place to another, so it cannot be used at any place. So what we did is that we wanted to provide an alternative. We wanted to build a device that is portable, cost effective, and it can be used anywhere, any place. It can be used to measure the milk quality instantly, just like people measure their temperature or blood pressure. And in this device, we targeted four adulterants. First, we targeted detergent and urea, and for that we used pH meter, and then for the excess water we used a density meter. So these two adulterants were measured directly through sensor devices, and for the other two, that is fat and protein content in the milk, we used machine learning model. And what we did is that we used the principle of light spectroscopy, that is the absorption and reflection of light particles through the milk sample, and we used that data to predict what fat and protein content is present in the milk. So our central processing unit that was present in this device was a Raspberry Pi. It was used to host the machine learning model, and it is very cost effective as compared to the other custom solutions available. So these are the results of our machine learning model that we used. We used a PLS regression model, and as we can see in our first result for fat prediction, we see that our root mean square is around 0.147. So it is very low, and the accuracy, that is R square, on training data is 98%, and for unseen tested data it is 90%. So as we can see on this graph, this green line is an ideal model, and the values that we predicted is shown as in the red line. So we can see how much our model was accurate and how much it was close to the real values. So it was successfully used to predict the fat content in any type of milk that was present. And for protein content, as the protein particles are very small as compared to fat particles, it was a little bit difficult to detect. That is why our model had an accuracy of around 83%. That was also commendable, and there is no other model that is present that can have that much accuracy. And we had 70% accuracy on unseen tested data. The reason it was lower than fat was because the light source that has to be used is infrared, and it cannot be visible wavelength light. So that is why it was 70% accuracy, and it can be increased by using a very sophisticated light source. So what we are providing is a cost-effective solution to the foreign product that is currently imported in the country. And as you can see, this is our working prototype. It is very easy to use. You just have to plug it into a laptop, and the quality parameters of the milk can be seen through the software that we are using. Another feature of our product is that you do not need to calibrate it. It is self-calibrated, so there is no technical expertise that is required. It can be used just like any other device, and there is no calibration needed. The AI is being used inside to self-calibrate it. So this is a device that can be used by any common layman person without any training, and they can use it at any place, anytime. So all of the components that are being used in this device are locally manufactured, except our central processing unit, Raspberry Pi, that is outsourced from China. But we have a very trustable vendor there, and the good news is that we are already in agreement with the government. We have already applied for an incentive, as we are a startup, so we are exempt from any kind of tax and tariffs for the next 5 years. So I believe that with mass production and a lot of marketing, our device can stand at around 20,000 Pakistani rupees, that is $80. We are providing the same level of quality that a lactoscan device is providing, with 10 times less price. So the $750 device is competing with our $80 device. Although most of the people said that they want to have a device for 10,000 rupees, that is $40, but what we decided is that we can have two variants of our device. The first one could be that will only measure pH and density, and it does not have any AI in it. And the second device that I just presented to you will have AI as well. So the first variant could be very cheap. It could be at around $5,000, or maybe 5,000 rupees, or maybe around $20. So it will be very cheap, and it will already cover around 80% of the adulterants that are being used in the market. However, for the other device that will cover around 95% of adulterants will be $80. It's very easy to use. Both of these devices will have no training required. It will be used just like a thermometer, just like someone measured their blood pressure. It can be used any place. It can also be used by milk vendors to set a standard to show the people the quality of their product, and it will build a trust between customers and vendors. In future, we will build similar kind of devices for other products as well. For example, one of other ideas we have is water quality meter that we use to measure the quality of water, and I think it will also be very popular and widespread among the people, because there is no such product already available in the market. So this is one thing that we are currently working on. The other is that we will enhance the accuracy of our model through more testing and more covering more adulterants. So what we need from you is an initial funding amount that is around 1 million Pakistani rupees, so that we can start the production of our initial batch. This initial batch will be used to test our product in the 3 big metropolitan cities, and we will see how much successful our device is and how much impact does it have. We also require some research facilities from you, so that we can enhance our machine learning model. We require some spectrometry, and we also require some milk sampling, so that we can cover all local milk shops. And we need some marketing and logistics support from you. We need a digital marketing team and also a supply chain team to set up our distribution centers and to promote our product. So thank you so much for listening. I think Siemens is already a big player in Pakistani market, and with this device, I think it will have an added advantage over its competitors, because through these kind of devices, they will set the standard for their quality. Thank you so much.